Okay, so this is after we tuned the gate down here. We made a wider gate, and we're still 24% is difficult to fill. So this is kind of showing you how the material's coming in, and it's pushing right here. One thing that we got, so it might not fill right there, but this is where we're going to put venting. So we'll take the next section of the learning and talk about venting and how we vent the gases out of here. But for the most part, we're filling, and it really becomes a game of opening up this gate right here, making it a little bit bigger. And as it gets bigger, we get better flow. And obviously, the venting that would come off of each one of these, we'll talk about that in a separate subject. But that's, and there's just a little bit of difficult. So anyhow, that's what we've got, and we'll keep going. So here's the molding machine, and I just want to talk a little bit about it while it's calculating our mold flow analysis, but this is called the hopper here, and we pour all the plastic in. Sometimes if it's a highly automated routine, we'll bring a big tube over and we'll pull from a box or a big silo like they store grain in, and it just automatically feeds it in here. At this point in the process, the colors are mixed here, and you can add drops of colorant to raw materials, and this screw, as it turns and it pushes forward to pack out the mold, it blends the colors here at the point going out. So there's systems that we can plug in, and it just gives it so many drops of a certain type of colorant, and then the plastic, as it melts, it carries it through and blends it. And so this is the barrel right here, and then the screw. The barrel is around the screw, and it's hot. It's got some heater bands around here. I think this represents a heater band. There's like 3 or 4 or 5 zones. Here's a heater band, and then this tip has a heater on it, and this is going to be butting up next to our mold here. And so when we start processing, at the beginning we won't be packing out the part. We'll only get it half the way through until the mold starts heating up. And so the first, I don't know, a couple dozen parts will be scrap, and then we start getting good parts. And this is what I was about to talk about next, which is the venting. So venting is a way of getting the gases out of here. So as you can see, the material coming through, it's got to push all this air that's trapped in there. So we're going to put these really thin features in here to vent out the gas, and we're going to have a discussion about that. Okay, so we made some modifications to this runner. We've already run a couple simulations, but we obviously widened the gate. We also did a couple other things. We put radiuses, and we made more of a mass here so we can get some pressure backed up into here. And we added some radiuses to let it flow through there. We still like some of these sharp edges for shear heat. It creates heat when this starts cooling down. It goes back up into temperature. And so one of the cool things that I just wanted to go over is that when we go to select a material, so we study a material, and this polyamide nylon has already been selected, and so I click over here on this particular material. You can simulate a number of different materials, but what's cool that I wanted to present to you is that the recommended processing is so cool that they've got like the ejection temperature of the mold, the absolute maximum melt temperature, and the lower melt temperature. So it goes from 290 C to 320 C, and then the mold surface temperature. So a nice way to measure how things are processing is with a thermal imaging gun that you can point at the surface of the mold, and you can get that mold surface. So this information will help us when we get to the molding machine. And so the transition glass temperature is kind of in the barrel when it's going out the barrel into the mold. It's going to be at 227. And then these heat properties and mechanical properties, this stuff is really strong. 3,000 millipascals are just massive amount of tensile strength. So these are some great processing tools for processing out at the molding machine once we get this tool built. So I'm going to leave this right here, and I'm going to then go to my injection point, and I'm going to I'm going to get rid of this, and I'm going to add a new injection point right here. I'm going to add one, and I'm going to put it right here at the top. And I'm going to actually take this, and I'm going to delete that first one. For some reason, we've got to get rid of that. And then we want to add a point right up here at the top, and then you hit OK. And so now our injection point, we can see it right here, right? That's where it is. Whoops. Here we go. Okay, we hit OK. And so let's try processing this again. And what we do is we go up and we say, we come to this study right here and we right click on it, we say solve. And so we can pre-check it or we can solve it, but let's just solve it. And it goes out to the supercomputers and it's going to solve this. And this takes about 45 minutes for the supercomputers to run and process all this information. So let's see how it turns out on this next run, and we'll show you the results here soon. Okay, so here's the flow with the new runner in here, and let's just play it for you. So this is basically 1 second of fill time. So within 1 second, most of the plastic has made it to the end of that. So it looks like our cycle time is going to be about 1.5 seconds to fill the cavity, and then the rest is cool time. So we can look at some of the things like plastic flow and how it flows through here. And so this is the work that the supercomputer has simulated and how the material moves around in the cavity. So there you go. Okay, let's see. Whoops. Here we go. So I wanted to talk a little bit about venting and where you need it and why you need it. And this particular part's pretty good for venting. We know that the plastic can kind of flow down this path and through the middle here and get out this end. And we'll show you the vent on there. But when there's a situation that a boss is here, let's just say this boss extends up. Let's see here. Whoops. All right, so we take this. Whoops. No. E. And let's just say this is really tall and it goes way up here like this. The plastic, when it goes to leave to get out of here, it burns down at the bottom of this thing here. So just imagine like all the particles flowing down this long beam here, and it's getting pushed from the center out, and it gets to here, and it's got to go down into here. What happens is if you don't have venting down here at the bottom of this boss, then it starts burning right in here. You'll see these black marks if there's not enough venting on the part when it comes out of the mold, and sometimes it gets real brittle and doesn't pack out. And so a lot of times we just take the pin that's there, the core pin, and we grind a little flat on it. So imagine there's a pin that makes this, and we just grind a little flat right across here and at a very small amount, and then the gases can run down the side of the pin. So that's venting on a boss, and I just wanted to show you that. And now we're going to go into look at this mold side, not this side. So this side is not a good side for venting for a couple reasons. And the pins that we just talked about, if we wanted to vent it running a flat down each pin, we can grind a little flat and do it there if we're having problems. But the easiest place to do it is on the A side of the mold. And here's why. So we've cut this cavity out, and then one of the last things we're going to do is we're going to put in this really thin sliver here. It's like 0.1 millimeters deep. And I think it's like, I don't know, 15 millimeters from side to side. This is a 20 millimeter step here. And we chase the gases out through this little thing. And if we make this too deep at the beginning, we'll get flash. And there'll be like this little knife blade of plastic that squirts out through here. So we kind of want to sneak up on it. And if for some reason we go too deep, we can always make this, we can just remachine it and set this down like a 1/2 millimeter or whatever and clean it all up. And then it's still, the mold will still close and it's just a little bit deeper. So this is kind of finicky in here. This is just a little step. This is, I don't know, 1/4 millimeter. This is a 1/10 millimeter. And that's why we do it on this side of the tool, because we don't have to worry about all those ejector pins. So, you know, if we're looking at this tool right here, all these pins would have, if we had to send this cavity down deeper to tune it, all these pins would have to get chopped on these surfaces to make it all shut off properly. So that's kind of why we do it all on, we try to do it on the A side, all the venting. Now the venting and the runners all come together, making one great thing happen. And we're back here at the mold flow version of this.